Straight lines. We're going to look at a few things about straight lines. First of which we're going to look at is we're going to look at the gradients. The gradient is a measure of the steepness of the line. We can work out the gradient by calculating the increase in y divided by the increase in x. I'm careful here not to say change in y because you've got to know that it's going bigger or if it's going smaller. That would be a positive gradient or a negative gradient. Positive gradients go up, negative gradients go down. How we're going to work this out is we're going to look at 2 points, two generic points, so we'll call them x1, y1, x2, y2. And we're going to look at how much it's gone up in the y. We're going to calculate that by doing y2 minus y1. Similarly with the x, we can calculate it by x2 minus x1. So our formula for the gradient is going to be m equals y2 minus y1 over x2 minus x1. We use the letter m for gradient. We're going to look at the length of a line. We're going to work out the length of the line based on Pythagoras' theorem. That's how it's all going to work. We're going to take our line segment, that means it doesn't go on forever in both directions, and we're going to call the two endpoints x1, y1 and x2, y2. The length of the line we're going to work out using Pythagoras. We're going to do the difference in the two x values and the difference in the two y values. So we get x2 minus x1 and y2 minus y1. To work out the length of the line, Pythagoras' theorem just says the square of the two sides added together is equal to the square of the hypotenuse. So we can work out the length of it by doing the square root of x2 minus x1 squared plus y2 minus y1 squared. Something else we'll consider is the midpoint. The midpoint is very useful for when we're doing perpendicular bisectors and stuff like that. The way we work out the midpoint is finding the average of the two x coordinates and the average of the two y coordinates. We can find the average very easily just by adding them together and dividing by 2. Sometimes it's easier just to look at the coordinates and to write down the number in the middle. But if you ever have to deal with anything algebraically, it's always nice to have a formula to fall back on. So add the two coordinates together, divide it by 2. We'll look at an example that uses some of these ideas. So we've got our line, this one's got a negative gradient here. We've got two endpoints, we've got P and Q. P has coordinates 1, 7, Q has coordinates 10, 3. M is the midpoint. What we're asked to do is we're asked to find the gradient of PQ. We'll do this by doing our formula y2 minus y1 over x2 minus x1. That tells us 3 minus 7 over 10 minus 1. It doesn't matter which one you pick as y1 or which one you pick as y2, so long as you're consistent and you have the same x that matches it. So that tells us our gradient is minus 4 over 9. Now we want to find the coordinates of the midpoint. Notice this is a capital M, and for the gradient we use a lowercase m. So the value of the coordinates of the midpoint, we can just add together our two x coordinates, add together our two y coordinates, and half them. So we get 11 over 2, and we get 10 over 2, which is 5. Last idea I want to pull out of this is we're going to find the length of the line PQ. Remember, to find the length of the line PQ, we're just going to use Pythagoras' theorem. We consider y2 minus y1 and x2 minus x1, but we've already worked these numbers out in our finding of the gradient. So we know that 10 take away 1 is 9, and we know that 3 take away 7 is minus 4. Remember that a negative squared, the minus times the minus is just a plus. That gives us 9 squared, which is 81, plus minus 4 squared, which is positive 16. So that tells us what we've got the square root of 97. Thank you.